Picture this, a vast swirling cloud of gas and dust. This was the solar nebula, the birthplace of our sun and all its planets. Mostly hydrogen and helium, the simplest elements in the universe. Heavier elements, forged in long-dead stars, would become planets and life. The solar nebula was a chaotic nursery, filled with raw materials. Gravity took hold, clumping particles together. The nebula began to shrink and spin, forming a swirling disk. At its heart, a star was born, our sun igniting the solar system. Deep within the swirling heart of the solar nebula, the pressure and temperature continued to rise. The hydrogen atoms, squeezed together with unimaginable force, began to fuse. This nuclear fusion, the same process that powers the stars, released a tremendous amount of energy. Suddenly, the center of the nebula burst into brilliant light and heat. Our sun, a newborn star, had ignited. With the birth of the sun, the solar system began to take shape. The intense heat and light pushed the remaining gas and dust away from the center, creating a vast, flattened disk. This disk, known as the protoplanetary disk, would become the breeding ground for planets. The sun's gravity acted as an invisible shepherd, keeping the material in the disk orbiting in a stable plane. Within this disk, the seeds of planets were sown, ready to begin their own epic journey of formation. The birth of the sun was not just the start of a star's life, it was the dawn of an entire solar system. Billions of years ago, our solar system was a chaotic construction site. Whizzing around the newborn sun was a messy disk of gas and dust. Within this disk, a remarkable process was underway, the formation of planetesimals. Imagine these planetesimals as cosmic dust bunnies. Tiny grains of dust drawn together by static electricity began to stick together. Over millions of years, these dust bunnies grew larger, forming pebble-sized objects, then boulder-sized, and eventually, objects the size of mountains. These planetesimals, swarming around the young sun, were constantly colliding with each other. Most of these collisions were destructive, smashing the objects back into smaller pieces. However, some collisions were constructive. When two planetesimals of similar size and speed collided at just the right angle, they could stick together, their gravity pulling them into a single, larger object. This process, known as accretion, is how planets like Earth were born. Over millions of years, these planetesimals, through countless collisions and mergers, grew larger and larger, eventually becoming the planets we know today. What were once tiny dust particles had transformed into the building blocks of entire worlds. In the early solar system, Earth wasn't the solid, life-sustaining planet we know today. It was a hot, molten world, constantly bombarded by asteroids and comets. As Earth grew, its gravitational pull intensified, pulling in more planetesimals. These impacts generated immense heat, melting the surface. Imagine fiery oceans of molten rock reshaped by impacts. Intense heat caused heavier elements to sink, forming Earth's core. These fiery beginnings were essential steps in Earth's evolution. While Earth was still in its molten infancy, a cataclysmic event occurred that would forever shape our planet and its destiny. A Mars-sized object, which scientists have named Theia, collided with the young Earth in a colossal impact. This impact was unlike anything Earth has experienced since. The energy released was unimaginable, vaporizing vast amounts of rock and flinging debris into space. Theia, largely destroyed by the impact, merged with the molten Earth. The debris ejected into space didn't simply vanish into the void. Bound by gravity, it began to coalesce, forming a ring of molten rock and dust around the wounded Earth. Over time, this ring aggregated, clumping together to form a new celestial body, our Moon. The Moon's formation was a defining moment in Earth's history. It not only gave us our celestial companion, but also stabilized Earth's rotation, creating a more stable climate. The tides, driven by the Moon's gravitational pull, would also play a crucial role in shaping Earth's coastlines and influencing the evolution of life. The Moon, born from a cosmic cataclysm, is a constant reminder of the dynamic and often violent history of our solar system. After the chaos of its formation and the dramatic impact that formed the Moon, Earth began to cool. As the planet's surface solidified, volcanic eruptions became a dominant force. These eruptions, spewing gases from Earth's interior, played a crucial role in forming our planet's first atmosphere. This early atmosphere was very different from the one we breathe today. It was a toxic mix of gases like carbon dioxide, nitrogen, water vapor, and methane. There was no free oxygen, the gas we need to breathe. Despite its inhospitable nature, this early atmosphere was a crucial step in Earth's journey towards habitability. It acted as a thermal blanket, trapping heat from the sun and keeping the planet warm enough for liquid water to exist. This early atmosphere also shielded the surface from harmful solar radiation, paving the way for the emergence of life. Although toxic by today's standards, this primordial atmosphere was a sign of Earth's transformation from a molten wasteland to a planet capable of supporting life. As Earth continued to cool, something extraordinary happened: rain. The water vapor in the atmosphere condensed, forming clouds and unleashing torrential downpours that lasted for millions of years. These rains filled the low-lying areas, creating the first oceans. The arrival of liquid water was a turning point in Earth's history. Water is essential for life as we know it, acting as a solvent for chemical reactions and a medium for transporting nutrients. The early oceans were far from the pristine blue waters we see today. They were likely acidic and filled with dissolved minerals and gases from the atmosphere. However, even in this early state, the oceans provided a stable environment where complex organic molecules could form and interact. The stage was set for the emergence of life in Earth's primordial seas. The oceans, formed by the relentless rain of a cooling planet, would become the cradles of life, nurturing the first single-celled organisms and setting in motion the extraordinary journey of evolution. Cradled in chaos, the genesis of life's stage, the early Earth was a world in constant flux. Volcanoes erupted, spewing lava and gases into the atmosphere. Yet amidst this chaos, life found a foothold. Early oceans, rich in minerals, provided the perfect environment for life to emerge. These first life forms were single-celled organisms, similar to bacteria. Their emergence marked a profound turning point, transforming Earth into a living biosphere. From fire to water, a delicate balance emerges. As life began to flourish in Earth's oceans, it started to influence the planet itself. The early photosynthetic organisms released oxygen as a byproduct of their metabolism. This oxygen, initially absorbed by rocks and minerals, slowly began to accumulate in the atmosphere. This great oxidation event was a pivotal moment in Earth's history. It led to the formation of the ozone layer, which shielded the surface from harmful ultraviolet radiation, making it more hospitable for life. The rise of oxygen also paved the way for the evolution of more complex life forms that could utilize this new energy source. This delicate balance between Earth's physical systems and the life it harbored was essential for the planet's continued habitability. The very act of life transforming its environment, releasing oxygen into the atmosphere, ensured the conditions for its own survival and proliferation. This intricate interplay between life and the planet would continue to shape Earth's destiny for billions of years to come. A legacy of change, Earth's unending evolution. Earth's story is one of constant change. Continents have shifted, mountains have risen and eroded, and ice ages have come and gone. Life, too, has been shaped by these changes, adapting to new environments and evolving into the diverse array of species we see today. From the first single-celled organisms to the emergence of multicellular life, from the Cambrian explosion of life forms to the reign of the dinosaurs, Earth has been a stage for an incredible drama of evolution. The impact of asteroids, volcanic eruptions, and even the slow drift of continents have all played a role in shaping the course of evolution. Extinction events, though devastating, have also created opportunities for new species to evolve and diversify. Earth's story is a testament to the resilience of life, its ability to adapt and thrive even in the face of dramatic change. A pale blue dot, our place in the cosmos. Looking back at Earth's tumultuous beginnings, it's awe-inspiring to realize that our planet, born from a chaotic cloud of gas and dust, has become a haven for life. From the violence of its formation to the delicate balance of its ecosystems, Earth's story is a reminder of the preciousness and fragility of our existence. As we explore the cosmos, searching for signs of life beyond our planet, we carry with us the legacy of Earth's epic journey. The story of our planet's birth, evolution, and the emergence of life is a source of wonder and inspiration, reminding us of our place in the grand tapestry of the universe. We are, after all, children of the stars, born from the same stardust that makes up everything around us. And as we continue to explore the cosmos, we do so with a deeper appreciation for the pale blue dot we call home.